Hello, Martin Rees here. Hi.
Oh, fantastic.
Hello,
Hello.
Martin.
Can you see
Hi,
us?
Tom. I can see you all. Yes, yes. Mhm.
This
Seems
is
Yes.
my
hard.
son at the end, Martin, and my daughter-in-law.
Hello.
Oh, great. Okay, yes. Very good to see you. And greetings to you all from Trinity College. I'm in fact at my home, which is in Herschel Road, next to Clare Hall.
How is Paul Trinity coping, Martin? Is everyone more or less still afloat?
Yes, well, labs have opened up for experiments, and more buildings are opening up. But of course, in Trinity, the plan is to have all the students back in October. And that's a big risk. They can't give them all en-suite facilities, but the idea is to have them in groups of about 6, sharing toilets and all that. So if one in each group gets sick, then the other 5 have to isolate. So that's the compromise. And the big lectures are going to be done remotely, although the small tutorials will be done live. That's the idea.
Well.
So, shall we, do you like to have a short introduction here? Who is who, or Martin? Or shall we start straight with a discussion? What do you prefer?
Well, let's start straight away, but I guess everyone is a Trinity alumnus, is that right?
Except for Max and Max's wife.
Oh, right.
But they are affiliated through their father. Otherwise, everybody is Trinity, either graduate from Trinity alumni or visiting fellow commoner.
I met you in Trieste 3 years ago.
Oh, right, yes. Well, anyway, it's very good that you're committed to the college and you're getting together in this way. And I'm really sorry that I'm not with you to actually join in your food afterwards.
Well, we can send you some, but shall we start with a discussion if you like? Yes.
Well, I'm in your hands, Gerhard.
Okay. I think we thought we could highlight the great strength of Trinity College in exoplanets now, with and life outside Earth, with a recent Nobel Prize of Didier Queloz, which maybe you are working on similar areas as well.
Yes.
So maybe that's a good way to start the discussion. What do you think?
Yes. Okay. Well, let me just say a little bit about that. Didier Queloz, he got the Nobel Prize last year for discovering the first evidence for planets around other stars. Of course, we know about the familiar planets in our solar system, Jupiter, Mars, and the rest. But we suspected that other stars, which are really rather like the sun, would be orbited by retinues of planets. Of course, the planets would be much fainter than the stars they're orbiting, and so it's not been possible to see them. But what Didier did back in 1995 was to find the first evidence for a planet around another star. He found that because he could detect a small wobble in the star position due to the gravitational pull of a planet going around it. And this was the start of a really exciting new field of astronomy. And we now
measure the modulation of the light intensity from the star.
Well, there are 2 methods. His method was to modulate the change in the Doppler effect. But as you say, the most successful method afterwards has been to look at lots of stars and note that if a planet transited across in front of them, it would block out a bit of a light. So if you find these transits, you've learned 2 things. You can learn what the planet's year is from how long it is between successive dips, and from how much the starlight is reduced, you can infer how big the planet is. For instance, if there were aliens looking at the solar system from a long way away, they would see the sun as an ordinary star, and whenever the Earth transited across in front of us, the sun would get fainter by 1 part in 10,000.
Okay.
That's because the Earth is about 1% the radius of the sun, so
yeah, yeah, yeah.
1 part of 10,000 of the area. So
Yeah.
so you're detecting that, but that's been done for thousands of stars, and so
Oh.
we now know that most stars
Uh-huh.
have retinues of planets orbiting them,
Uh-huh.
but they're not all like the ones in our solar system. There are some big planets like Jupiter very close in, so their year is only a few days, and many others, but it's a very, very exciting field. And of course, as you say, it revives interest in whether there's life on any of them. We don't yet know, but to link with history, of course, if we go back to the 19th century, then of course people only knew about the planets in our solar system, Mars and Venus and Moon, of course, but it was a popular view that there was life on all of them.
Okay.
And of course, now we know that there's certainly no advanced life of any kind, but people talk seriously about life on Mars and even life on the Moon. And this was partly really for theological reasons. I mean, Whewell and others, they thought, what a waste of space if God doesn't fill all these planets with life. Lovely quote. There was Brewster, who's a physicist. Some of you may know the Brewster angle in optics. He wrote a book about this, and he thought that the Moon must be inhabited, and he had this lovely statement in his book that if the Moon had simply been put there to light up the Earth by God, then why would it have all these craters and things? He said, a lump of chalk would suffice, he said. And so the fact that the Moon has, as you know, craters and mountains, he thought that indicated it must have been designed to be inhabited. And William Whewell, of course, who was the polymath who was Master of Trinity in the 1840s and 50s, Whewell, he actually changed his views. He started off thinking that there would be life on Mars and Venus, etc. But I think he changed his views a bit because when he realized that fossils exist on the Earth, he realized that God was rather wasteful. And he then felt it was possible that God did waste all this space and not have anything there. So Whewell was someone who was guided by philosophy and theology. And incidentally, although he's famous as a polymath, and he in fact coined the word scientist, he didn't favor teaching science. The natural sciences tripos at Cambridge didn't start till about 1870. And they had mathematics, of course, and things. And Whewell actually says in one of his books that students should be taught the eternal verities of theology and mathematics, not transient science, although he did eventually say that any scientific idea that had been established more than 100 years ago, that was okay. But it's interesting that science as a part of the tripos started in 1870, and that's of course when the Cavendish lab was built.
And you talked about Mars. Now, would you buy a return ticket or a single ticket?
Sorry, can you say it again?
Sorry, you mentioned Mars. So you mentioned in your book also about the question of single ticket or return ticket or time.
Oh, right.
Yes.
And, well, I mean,
would you buy a ticket to Mars if once that works?
One way ticket. Well, let me put a bit of background to this. Of course, there's a lot of interest in Mars. There are 3 unmanned probes that have been launched just in this last month to go to Mars, to land and to study its surface. And the question is, will people ever go? And you know, I'm old enough to remember Neil Armstrong's one small step on the moon. And at that time, which is over 50 years ago, I thought that there would have been footprints on Mars long before today. It was only 12 years from the first Sputnik to men on the moon.
Yes, yes, yes.
But of course, what happened was that the Apollo program to land men on the moon was fueled by superpower rivalry. And the Americans had spent 4% of their federal budget on that.
Okay.
But having beaten the Russians in the race to the moon, there was no incentive to keep going. And
Right.
therefore, they cut back, and there was no motive to go further. And if we look at what's happened in the last 50 years, then, of course, humans have been into space, many hundreds of them, but only into low Earth orbit, orbiting around in the International Space Station, which isn't very glamorous. It doesn't make the news unless something goes wrong, unless the toilet fails, or there was a Canadian astronaut who played a guitar and sang David Bowie songs up there, you know. So it's rather unglamorous. And the reason that manned spaceflight has become less important is that robots and AI can do much better. And advances in miniaturization and robotics means that if you want to explore the surface of a planet, if you want to build a structure in space, fabricate something, you don't need people. And so it's far cheaper, obviously, to send up robotic fabricators and robotic probes. And that's happening in a big way, as you know. But of course, there is the yearning for adventure as a human goal to send people into space. And my take, and this is what I do discuss a bit in my book, is that I don't think that it makes much sense for NASA or its European counterpart, ESA, to send humans into space. The reason is that they've got to be so risk averse. They're using taxpayers' money to send civilians. And that's certainly true in America, because in America they launched the space shuttle 135 times. And it failed just twice. And each of those failures was a big trauma in America, and they held up the program. But a less than 2% failure rate, that's fine for test pilots and fine for all kinds of adventurers, you know, around the world, balloonists, people who go hang gliding in Yosemite, etc. So my view on manned spaceflight is that we should welcome these private space companies like SpaceX, which is Elon Musk's company, and Blue Origin, which is Jeff Bezos's company. They can use cut price technology, Silicon Valley techniques, and they can also take much higher risks. And there'll be volunteers who will go, and as you say, there will be volunteers with one-way who will go for one-way tickets. So I think it's quite possible that the first humans to go to Mars will be privately sponsored, privately funded, accepting a high risk and maybe a one-way ticket, because it does, the return trip obviously is expensive, because you've got to have on Mars already a return vehicle and all the equipment, etc. So probably a one-way trip is about 10 times cheaper than a return trip. And so for that reason, the first people may go on a one-way trip. And Elon Musk himself, who's now, I think, 49 years old, he said that he wants to die on Mars, but not on impact. And he might make that. But let me just put in the proviso here. Elon Musk and my late colleague Stephen Hawking, they thought that there would be mass emigration of normal people to Mars, millions of people, as insurance policy and to escape the Earth's problems, etc. And I think that's a dangerous delusion. Because nowhere on Mars is as comfortable as living at the South Pole or at the bottom of the ocean. And there's no great demand to do that. It's a dangerous delusion to think that we can escape climate change by going to Mars, because terraforming Mars, to give Mars an atmosphere that humans can live in, is far, far more difficult than dealing with climate change on the Earth. So it's a distraction. But just to finish this, if we think a long way ahead, and of course astronomers realize that although the Earth's been around for 4.5 billion years, it's got an equal amount of time ahead of it, then we could think of sort of evolution beyond human beings. And that evolution is not going to be Darwinian selection, which is what's led to us over the last 3.5 billion years. it's going to be technological. It's going to be a human enhancement by genetic technology or cyborg technology. And that's going to be much, much, much faster. It takes
I read this in your book and I didn't quite understand that. You mean that humans are going to make operations in implanting chips, for example, and that will be incorporated in evolution? Or how can we envisage that?
This has been talked about already. I mean, having chips.
Yes, sure.
Yes, and so my scenario is that, you know, by the end of a century, we will understand how to do that sort of thing, and also be able to do, if we wanted to genetically modify a human being. We'll understand how genetic code determines people's characteristics, and we'll be able to synthesize a genome.
Okay. And that will flow into Darwin's evolution.
Well, and this will mean that we will. This could happen on a much shorter time scale.
Yes.
It works out my great-grandson's going to be a combination of Max and that robotic helicopter that the Americans are sending off to Mars.
Right, yes. But I think I don't know what you feel, but I feel that all these technologies should be heavily regulated on Earth. We shouldn't
make it
we should try to prevent
Max and the helicopter. Maybe there should be something.
But I think
great idea.
Gene editing and all that is controversial, and we shouldn't allow it. But these crazy guys on Mars, they'll be beyond the power of the regulator.
Yes.
And there's a far greater incentive because we're pretty well adapted to living on the Earth. They're badly adapted to Mars. So that's why I say in my book that the first sort of post-humans will be descendants of these crazy Martians, because they will be able to use these technologies and they'll have an incentive. Now, the extent to which they remain flesh and blood or sort of become more electronic, we don't know. But it's quite possible that this will happen. And so the future evolution, maybe not on the Earth, but beyond the Earth, will be what I would call sort of secular intelligent design. It'll be planning human beings with different genetics. And this is, I think, a nightmarish thought. So we don't want it to happen on the Earth, but the knowledge will be there by the end of a century.
They can come back
and the people who might be free to use it and who we should cheer on using it would be these crazy people on Mars.
I might come back to bite you.
But the atmosphere on Mars is pretty difficult. Now you have radiation and there's no magnetic field, and so it's not so trivial to live there. No?
Oh no, that's right. That's why it's very hostile for humans, and so the only people who will go there is crazy adventurers who are happy to live under some sort of bubble, and you've got to be in a spacesuit when you go out, because, as you say, the atmosphere has only 1% the density of the Earth's atmosphere. That's why, incidentally, it's such a challenge to land things on Mars, because parachute is very effective.
You'd have to live in a box there or in some incubator.
Yes.
Well, you know, there are a good many North American cities where people essentially live underground in winter, I suspect. I have a vision of Venus as a huge North American shopping mall.
Well, that's right. Yes, and well, a lot of people talk about this, and even the idea of having huge things up in space, which are like a Californian suburb, you know.
And in your book, you mentioned that you expect life on other planets to be found within 50 years, which is even shorter than the crazy people on Mars.
You mean our planets, Martin, or these new planets that were discovered?
Yes. Well, I mean, I think, of course, these probes that are going to Mars now, they're going to look for evidence of sort of dead bacteria that might have existed.
Past life. Or,
yes, because we've got good reason that Mars was sort of had a lot more water and was more habitable in its early life, and so it's possible that there could be some life there. And in our solar system, obviously no one expects any sort of advanced life, but there are other places. In fact, Saturn and Jupiter both have moons which are ice with water underneath. There's a Europa, and Enceladus, and some people think there could be things swimming around under those, but nothing advanced. But I'll tell you why this is very important, because we now know, as I say, that there are literally billions of planets, rather like the Earth, in the galaxy, because there are 100 billion stars, and nothing. So there's a billion planets. And at the moment, it's conceivable, it's logically possible that the origin of life, the transition from complex chemistry to the first replicating, metabolizing systems, is so rare that it's only happened here. That's where we are. That's logically possible. We don't know.
Yes.
But supposing we did find evidence for life on one of the other planets in our own solar system, this would have momentous implications, because if life can evolve twice,
it's 3, 4, 5 times as well.
That would mean it was common and must exist in billions of places in our galaxy. And so there could be biospheres around them. And at the moment, we can't, with our present telescopes, actually observe enough light from these exoplanets. It's rather like if you were looking at our solar system from the distance of a nearby star, the sun would look like an ordinary star, and the Earth would be, in Carl Sagan's nice phrase, a pale blue dot. Close to its star, our sun, but a billion times fainter. Very hard to see. But if the aliens had a big enough telescope to actually observe that pale blue dot, they could infer quite a bit about us, because the shade of blue will be a bit different depending on whether the Pacific Ocean or the landmass of Asia was facing them. So they inferred that there were constants and oceans. They could infer the heat of the day by taking the spectrum of the light. They could infer that the green things, maybe chlorophyll and oxygen, etc., and infer that it was a biosphere. And we can't do that now, but telescopes now being built will be able to collect enough light. There's one European consortium is building a telescope in Chile, which has a main mirror 39 meters across. And 39 meters, pretty vast. And that can collect enough light from a planet around an ordinary star to actually analyze that light. And so within 10 or 20 years, if biospheres of some kind are widespread, we will know. Now, of course, what people then ask is, what about intelligent life, aliens, etc.? Of course,
I think Didier Queloz, I've seen, he has a program on life elsewhere, no?
Oh, yes, well, he's one of the leaders doing this sort of thing, and he's designed the instrument for this big telescope, which is optimized.
That's the same one you just mentioned now.
It's
I think, if you don't mind, we don't want to take too much of your time, but I've been doing the conversation all the time now. Some of us have some questions for you, which are quite different. Is that possible?
Yes, a lot of topics to discuss. So I'm very happy to
okay, great. I think so Peter, this is Peter Kilner. You know, he is a lawyer, and he has something for you now.
Hello, Rees. I just
can you hear it, or should he come closer to the microphone?
Can you hear me?
I can hear it.
Shall I come over?
Yeah, come closer then. Come here, then you can ask.
Right.
Hello. I had just a couple of questions. One was, and they're sort of connected. One was, you wrote your book, the most recent book, 2 or 3 years ago, and I was just wondering if you were writing it now, whether you would make any significant changes to it. And then the second, which sort of leads on to that, is you finish off, you conclude your book with, I suppose, I would say, sort of qualified optimism. And I'm wondering whether you're now more optimistic or less optimistic.
Yes. Well, I think still very qualified optimism, I would say. I think in my book, and incidentally, there is now a Japanese translation, but of course you're all English, but it is now out in Japanese and in 18 other languages, which is very nice. But to answer your question, I expressed pessimism about the consequences of the fact that we are more interconnected globally, we're more vulnerable, and I did mention pandemics. as a threat, and also massive cyber attacks and things like that. So I think one important new feature is that something can spread globally, have global effects. In fact, I worried in the book about not just natural pandemics, but engineered ones, you know, bio threats, etc. We haven't had those yet, but the situation is that, as I mentioned in my book, for the last 8 years, it's been possible to engineer the influenza virus to make it more virulent, more transmissible. It's not yet possible to do that for the coronavirus. It's more complicated, but that'll happen one day. And so I think we have to worry about not just recurrences of what we're having now, but possibly even malefactors trying to engineer and release them. And I think this is something which I think is really scary, but the fact that individuals and small groups can create something which could lead to a global catastrophe. This is true through these bio threats. It's also almost true for cyber, because if you have a cyber attack which knocks out the electricity grid in a large fraction of a country, in Japan or eastern part of the United States.
It has already happened. That has already happened in some countries, I think.
Yes, but not
in Europe.
Yes, but if it went on in a large region for several days,
yes,
then you'd have complete anarchy, because it's the lights going out, least of your problems, food and communications, computers and everything. And the point is that just one event like this is too many.
Yes.
And the way I put it in my book is that the global village will have its village idiots, but they will have a global range. And so we can't be so tolerant. And I mean, as a lawyer, I think I would make the point that it seems to me that the tension between three things we want to preserve, which is freedom, privacy, and security, is going to be harder in future, because I think we have a very strong incentive to ensure that some lone weirdo can't surreptitiously do these cyber attacks or generate a bioweapon. It's not like building an atomic bomb, which can't be done without special purpose facilities that can be monitored. These can be done using dual-use existing facilities. And I think it's a real concern how we can minimize this catastrophic risk, where one account is too many, without invasions of privacy, without ensuring that people can't do clandestine things like this. And so I think this is going to be a real tension for all societies. I mean, the Chinese will sort of solve it by abandoning privacy, but I think the rest of us will be more reluctant to do that. But I think it is going to be a problem, because one could be less tolerant of this risk when the consequences of such an event could be national or global rather than just local. So that's your first question, I guess. So I can't be optimistic, because I do worry about how we're going to cope with that kind of threat.
Yes, which you mentioned in the book. So yes, no change in the level of optimism.
Right. No. But I think we have a bumpy ride through the century. But and of course, I've had some bets with Steven Pinker, who's a great optimist. I don't know if you know his books, but he writes saying everything's getting better and better, etc.
Until the virus came.
Well, yes. Well, I mean, in many ways, you know, life expectancy and.
Oh yes, but the life expectancy in US is actually decreasing.
Well, that's right. That's right. Yes, but it's and so I think the positive trends have ceased in many areas. So I think this is a problem. But I think also he's one of these people who thinks there's been an ethical improvement. And here I will completely disagree, because he quite rightly says that life for people now is better than it was in the Middle Ages.
Yes.
But in the Middle Ages, there wasn't very much they could do to improve things. They didn't have the technology.
In the Middle Ages, they were drinking much more alcohol than today, so kind of suppressed the suffering.
Right. Things were pretty bad for them. And of course, when the Black Death happened in Europe, they were fatalistic and couldn't do anything about it. But I think now the gap between the way the world is and the way the world could be is much wider than it was in the Middle Ages, because obviously we have the technology to provide a decent life for all the 7.8 billion people in the world, and we're not doing that. And the 2,000 richest people in the world would have the resources to double the income of the bottom billion. They're not doing this. So I think we can't claim any global ethical progress, really, because the gap between what we could be doing and what we are doing is wider than in the Middle Ages, because what we could do is so vastly enhanced by the power of technology.
Do you have a question?
Just a small question. My name is Yasuhide, and just I'm talking about gravitational waves.
Yes.
After century, Einstein invented his equations, and gravitational waves are detected. Maybe this means directly. And then, are there any other aspect to be detected to establish Einstein equation, or Einstein equation is perfect in a sense of a macroscopic level?
Yes. Well, of course, as you say, I mean, Einstein's theory has been very hard to detect because it only differs from Newtonian theory under extreme conditions. There was the famous first test in 1919 when Eddington, Trinity College Cambridge, led an expedition to discover that light was bent when it passed close to the sun during an eclipse, and there have been some later tests, but only in recent years have astronomers been able to observe extreme conditions where Newton's theory isn't good enough. Newton's theory is excellent, except when speeds get close to the speed of light and gravity gets very strong. So we've had, in the last 10 or 20 years, more ways of testing Einstein's theory in applying to the Big Bang and to extreme objects like neutron stars and black holes. And it has stood up against these tests. What remains unfinished business for the rest of this century for theorists is, as you implied, to reconcile Einstein's theory, which is a theory of gravity, a weak force on large scales, with the quantum, which applies on very small scales. And this is the big challenge, to reconcile Einstein's theory with the quantum theory, and that'll be necessary if you want to understand the nature of space on a very tiny scale, because empty space may have a grainy structure on a submicroscopic scale, and the early Big Bang, everything was so dense that quantum fluctuation could, as it were, shake the entire universe. And so we need a new theory to handle those. But going back to gravitational waves, they are a prediction of Einstein's theory. Everyone knew they were very, very hard to detect. They're produced in principle whenever you have two objects orbiting around each other, or some object collapsing. But everyone knew that the only strong emitters of gravitational waves would be, for instance, two black holes or two neutron stars which spiral together and merge. Very violent event. And that's what they've been searching for. And they built the telescopes in America, and one in Italy. And of course, there's one being built in Japan, which will actually be in many respects an advance, because it's going to be underground and cryogenically cooled. But anyway, these instruments, the ones in Europe and the United States, they had great success for the first time 4 years ago in detecting gravitational waves from colliding neutron stars. And what's involved is amazing, because if a gravitational wave goes past you, and you have, say, two two mirrors or something like that, then the mirrors shake a bit. The space itself shakes around so that the two mirrors are pulled apart, then they're pulled together. And so what they try to do in these detectors is to have a laser beam to go between two mirrors and detect this small change. And that's what they did. So they can detect that this sort of chirp. It starts off like this and then speeds up and then dies away. And
this signal is,
but it is amazing because they have these two mirrors 4 kilometers apart, and we measure the amplitude of this wave is 1 million times smaller than an atom.
Yeah.
So there's tiny fractional change of distance. So some say it's rather like measuring the thickness of a hair at the distance of Alpha Centauri, 10 to the minus 21. And so this is an amazing technological feat that they've been able to do this. And that's been done by LIGO and by Virgo, and will be done by Kamiokande instrument, which is being commissioned now here in Japan. Yeah. But as I say, that understanding how we can reconcile quantum theory of the micro world with Einstein's theory, that's still a big challenge. So lots of work being done on it, string theory and things of that kind, but we don't yet have an agreed theory.
Thank you.
I think we don't want to take away too much. I think you're coming up for lunch. If I may ask a last question, you made a prognosis in the email which we exchanged a few days ago about your prognosis that we'll all be vegetarians and we'll all do what's it called, like a voluntary death if we get to euthanasia.
Yes.
And my comment to that was that we have this crisis concerning the food. No? I mean, the thought of vegetarianism concerns really the respect for the planet, no? Or keeping the planet right. But then our body is quite complicated, and there are industries which kind of exploit the action of, for example, sugar on the brain. And so there's some difficulty in addition to the vegetarianism. So our present master, of course, is an expert on this, but if you may have a comment on that.
Yes. Well, I mean, as you say, I mean, our diet is unhealthy, sugar and eating too much. And so, and of course, you mentioned the life expectancy in the US starts to go down, not up, and it's probably due to obesity and too much of the wrong food. It could be. So I think you're right in saying that the problems are in many parts of the world eating too much of the wrong food. So that's one reason for a change in diet. But the other reason really is that if we want to ensure that all the 7.8 billion people now on the earth and 9 billion by mid-century can have a decent diet without farmers having to encroach too much on forest land, then that means that there's something we can't do. We can't probably eat as much beef as Americans now do.
Sure.
And a vegetarian diet with perhaps intensive farming, which doesn't use too much water either, because water is going to be constrained as well.
Yes. And you will soon have your lunch now. Will that be vegetarian today for you?
I think it may be, yes. But I mean, I eat fish, but I avoid meat.
Okay.
I'm a gloomy old historian, Martin. My fear is in 20 years we'll be eating each other.
Well, that's a...
Thank you so much for...
Harry will appreciate that. She's a fellow Russianist. We tend to be gloomy.
Before finishing, can I just say...
Oh, yes, please.
Well, I mean, first, I mean, on the food issue, I think that's fine. And I also mentioned euthanasia, and I think
yes, that is.
Yes, these were for colleagues. When I was asked to predict two things by mid-century, I said more vegetarianism, and there's lots of reasons for that, and also more euthanasia.
Yes.
And the reason for that is that because of medical advances, the gap between how long we will live in a fairly natural way and how long we can be kept alive by maximum interventions is getting wider. And most of us feel that there's got to be some sort of limit, and quality of life is more important, and maybe the same issue for very premature babies. And I mentioned that in my book.
Yes.
And of course, this is a very deep ethical question. But I would predict that, given that the gap between people who can be kept alive and those who really would want to be kept alive if they were asked is getting wider.
Yes.
So I think there'll be more debate about under what conditions. One should allow people to die naturally, and very premature babies similarly. This needs to be out in the open, I think, and this become a more acute topic. And here again, different national cultures are going to have different attitudes. I mean, they already do.
And I mean, as a lord in the House of
predict as a tradition. Yes.
As Lord in the House of Lords, you have direct impact on the legislation. So,
well, it's interesting that there has been 2 or 3 debates on assisted dying, which is called.
Really?
Already, but it's rather interesting that I think most individuals in the House of Lords were in favour, and in fact, I remember the first debate was led by the great Lady Mary Warnock, who was a philosopher, and she was head of Cambridge College, but she developed the regulations for embryo research, you know.
Yes.
In the 1980s. So she was a very impressive person, and she was a leader in this debate. And it's rather interesting that the medical profession has been ambivalent about it, because they don't like to be involved in killing people, and they do worry that there'll be family pressure. And when it was a debate in the House of Commons, there was very strong opposition. It was about 400 to 100 against it. So MPs think that they don't want this. On the other hand, opinion polls show at least 80% in favour of something. So that you know, if you're very ill, well, you can now go to a place in Switzerland called Dignitas, where it's allowed. But people feel that should be allowed in the UK. But as I say, it's interesting. Members of Parliament were very cautious because they thought there would be severe ethical objections. So, as I say, the culture in Britain is very ambivalent about this, and of course the church is very hostile. And as I say, the medical profession is very uneasy about being involved in this sort of thing. Whereas in Belgium, it's gone quite a long way. So a big contrast even between Britain and Belgium. Good. So anyway, well, thank you very much. And before I go, let me just say I'm from the UK and Cambridge scene. I mean, we have handled this pandemic rather badly, as you will have read. But as I say, there's a hope for Cambridge to come back to fuller operations in October. And I think it's terribly important that the freshmen, the first year students, should be able to come into residence, because you can't sort of welcome and orient people remotely. So I think if there's got to be any selection, then I think most people think that the first year people should be the ones who should be encouraged to come back, because they need to meet each other, to meet us, etc. So let's hope that works. It's a big risk because they come from all over the world, as you know, and so there's a risk that this will trigger pandemics, but I think the university is trying hard to open up, and of course to hope that people will come. Some may try to defer for a year, which would be understandable, but we hope that many will come. But of course, another point I would make, which is a bit relevant to people in other countries, is that we will be developing more online resources, because we don't have big lecture rooms for, and so the big lectures, the introductory courses in mathematics and things like that, they will be online. And it seems to me maybe that will be okay permanently, to let people watch these very basic lectures. And moreover, Cambridge is rather behind, say, Stanford in making these materials available worldwide. And I personally think that it would be good if at least the good lectures of this kind were made available to the Open University and others for worldwide dissemination. I mean, this wouldn't lead to people getting a degree necessarily, but to actually enable people to watch them. I mean, for instance, Harvard, Michael Sandel, who's I don't know if he's a lawyer or philosopher at Harvard. He's become a sort of big star because his lectures on ethics.
I think you are also.
A little bit, but
your YouTube videos are also very popular.
Well, I'm not sure that you only get large numbers of viewers if you've been on the television a lot, which I haven't. But I think to do more of this, for people, say, in India, where the quality of the lecture in the average university is not very good, for them to have access to good courses from Cambridge and not just from Stanford would be good for us, I think. And so and no great, so as long as we keep our distinctive small group teaching and supervisions and all that. Well, Charlie, what do you think about this? Because you've had experience with Cambridge. And
I think that the key to our special teaching is precisely the small classes.
Yes.
I have no objections whatsoever to lectures going online. And I think that would be as you said, be a very useful form of overseas aid apart from anything else.
Of course, yeah. Yes, so I hope the university will go ahead with that.
Well.
Good. I saw. Yes, well, I saw incidentally that you've got Venki Ramakrishnan next month.
Yes. So I hope we have no problem with the virus, so that we can hold it in the same style again.
Yes. Well, he's of course he's been a bit more involved in this. I mean, he's been involved in the rather excessively acrimonious debate about when to wear masks.
I had an email discussion with him about that, actually. He
did, okay.
Yes. After you agreed to our conference today, then I asked Venki, and he also immediately agreed. And as a kind of pin-up for starting my email was that he had an investigation about the use of masks. So I for him, I checked at Shinjuku Station here in Tokyo, which is the world's most populated railway station. And I checked, and I found in changing the trains only 2 people who didn't have a mask, out of hundreds. So I sent him an email explaining that.
Yes, so I mean, I think it's been a rather stupid debate in Britain, really, about this. And people say it's a matter of freedom not to wear a mask, etc.
Well, in principle, you have the freedom to make yourself ill,
I'm doing it for the benefit of other people.
Yeah. Freedom to make other people.
Stop you infecting others.
Yeah, but there's a multiplication ratio, Let's say we are opposite to each other, and I'm sick and you're healthy. And if I wear a mask, there's a particular factor. If you wear a mask, there's a particular factor. But if we both wear a mask, they multiply, no?
Yes, and one point that Venki made, some people say, there hasn't been a sort of proper randomized controlled trial.
We discussed that with Venki. It's not a good argument.
The medical office and all, they all say, well, it's pretty obvious, and you can easily check it. We know that surgeons always wear a mask when they do an operation, and it's an obvious thing. And no one would say, well, we've got no evidence this works, let's have a test where half surgeons don't wear masks and half do, and see if more patients die in the one case than the other. No one would suggest that, because it's pretty obvious that the masks help to some extent. And he would say, well, that's the same in this context too. If everyone wears masks,
well, there were experiments, I think, here in Japan at the university, which used just water droplets for testing that.
Oh, really? Yes.
Without the viruses in the droplets.
Yes. Okay. Well, I have to say, today in Cambridge, it's the hottest day of the year. It's going to be 35 degrees, which is very hot for
that's hotter
England.
than here.
Yes. Good.
Yeah,
so what are you going to be eating?
Yeah.
What's your menu that I'm missing?
Oh, we have the menu. Yes. I think. Can you read it? Wait a second. Can you read it?
Yes, I can. Fish, yes. Deep fried rice. Fish dish. Yep. Okay. Oh, lots of fish. It's mainly fish, it seems.
Yes. Japan is fish mainly.
Yes. Yeah. Oh, well, very good. Yeah.
Not vegetarian.
Yeah.
You should come and join us when it's possible again. So
well, indeed, I will. Yes.
Fantastic.
Thank you, Martin. Bye-bye. Very good to see you. Yeah.
Well, very best wishes to everyone, and I hope to be in Japan. And in fact, the SCS forum is going to be remote this year, I think, in October.
Maybe you can manage next year, and we'd love to have you here in person, not only through video.
Well, yes, I'd like to come, because it's nearly 2 years since I was over last, and when I went to the Japan Academy, etc. Yeah. Good. Okay. Well, thank you very much indeed, and enjoy your evening.
Thank you. Thank you.
Bye-bye.
Thanks very much.
Bye-bye.
Thank you. Bye-bye.
Good wishes to Kate. Yes.
Bye-bye.
Right.
Bye-bye.
Bye.
So, here, end.
Right.